Yeah, I would like to talk about Ötzi. He's also called the Iceman in English. He has a lot of names, a man from the ice. Some people also call him Frozen Fritz in English. I don't know whether it's a Arabic name for him. Maybe you don't know the word ice at all. So, actually what we are doing and what we try is a bit really similar to what John was referring about. We have the mummy as a finding, and we try to get as much in detail and also try to get back in time for sure. Not that long, but for at least back to his time where he lived. So we can learn a lot of studying mummies or skeletons from ancient times. This holds true for all other kind of mummies. I'm also working a lot of Egyptian mummies, for example, because we want to like to understand how life was in these times. And this is a really, these people lived in this time is much more a direct evidence compared to any other archaeological evidence, where you never know whether this is telling you the truth. When you see nice paintings on the tomb walls in Egypt, you have the impression that life was so splendid, so beautifully, but if you have a look at the mummy, sometimes tells you a different story. And it's not only that we can learn about the life in ancient times, we can also learn about the life in modern times. We can investigate, study diseases, we can compare pathogens from ancient times to modern times. We can learn a lot from these ancient patients also for our modern day life. In this short talk I cannot go in detail into all aspects of the Iceman research we are doing, but I would like to give you the current state of the investigation, what we know about the Iceman. There are also a lot of rumors about the Iceman. I hope I can really give you the things we really are sure about the Iceman. And I give you an insight in the actual research we are doing. We are still having a lot of things we would like to understand, even if people think maybe after more than 20 years of research, it should be everything should be known of the Iceman. This is not true, because also the methods are evolving. We have new technologies, the DNA, the molecular biology technologies are evolving, the same with the physics. So there's a lot still to do, and I would like to give you a recent update of what we're actually working. So first I would like to show you where the Iceman was found. I'll tell you a little bit about his discovery. Maybe you know these are the Alps, the big mountains in Europe. And here in this little red circle, it actually, the Iceman was found. It was an area very close to the border between Italy and Austria. And it was funny because when the Iceman was found, he was found in front of the Mount Similaun in South Tyrol. This is exactly the place he was found. It was not clear in the first moment whether he belonged to Italy or Austria. So they came together, both sides, they remeasured the frontier between the two states, and it turned out that he was 92 meters on the Italian side. So the Austrians were a bit disappointed, but they were the first who were actually there, and then it was decided to bring the mummy to Austria first for the first years, because Austria in South Tyrol, in Bolzano, where it is now, there was no university, there was no way to study the mummy, so he was transferred to Austria for the first years. Then in 1998, he was brought back to Italy. So this was the situation the mummy was found. He was melting out of the ice. He was found by two German hikers on 19 September 1991. And in the beginning, nobody really knew what is this. This is just a human corpse that somebody, a mountain climber that died in the mountain. So nobody really knew what's all about this. There were two very famous mountaineers coming to the finding spot very in the first days. Maybe you heard about them, even if you're not so familiar maybe with climbing. This is Reinhold Messner, one of the most famous climbers in the world. And he was one of the people who was there, and he at least realized maybe this mummy could be, or this person could be some 100 years old, because it has a very strange, a very old-fashioned equipment. A problem was that this was not realized because the people were treating the mummy as a real archaeological find. You can also see his colleague Kammerlander leaning on this wooden stick, and this is a part of his backpack. And there are other images showing also Reinhold Messner with his sheath sticking into the mummy. So I don't know why, maybe he was trying to see whether he's still alive or not. And then even when the police came, the forensic doctors, the chief of the forensic institute in Austria, he said, the only thing I can say for sure, he died already some time ago. So it happened that they really pulled him out of the ice because the weather changed. He started to freeze again. It was very difficult. You have to realize it's more than 3,000 meters in height, so it's not a place where you really feel comfortable to work. And so they did also some damage to the mummy during the recovery of the mummy. But on the other hand, we cannot sue them because it was really a difficult time and nobody did really understand what it's all about. So I give you a kind of Iceman CV, what we know for sure about him. We know that he lived 3,300 BC, so he's more than 5,000 years old. He died at an age of 46 years, let's say between 40 and 50 years. This is the average. He was about 160, had a weight of 60 kilograms. He had several tattoos at his body, which is also quite interesting to see. He suffered from some intestinal parasites, which was maybe quite common this time period. He had some degeneration of spines and joints, and this has led, in the beginning, some people think he was an old man who was suffering a lot, was very ill. But come on, 46 years old, it's my age. I also have some back problems, some arthritis of the knees from sports, so this is nothing unusual. And he was, when we look at his muscular and attachments and the bones, he was a quite fit guy, so he was really used to walk in the mountains. And if you walk a lot in the mountains in this environment, you get some of these joint degeneration, which is nothing unusual. So this understanding of his life changed a lot, so we now are thinking he was in a quite good physical shape. So the question is why he died. This is for sure. So just a word to the tattoos. He has a lot of tattoos around on his body, mainly at the back and the other at the legs. And they're just simple stripes. They are not symbols, no animals. And we think now most probably it was a kind of treatment against his pain because he had back pain. And you see a lot of stripes here. He had pain in the knees, in the ankle joints. So most probably it was a kind of treatment against his pain. We know this from some other populations nowadays that they make incisions against pain to create a local pain that helps against the other pain. And most probably this was a kind of early treatment. But it's fascinating to see that already 5,000 years ago they did some tattoos. So he had a lot of equipment. This was also a very interesting finding because before, when this was found, we didn't really know how the clothing was, how the equipment was in the so-called Copper Age, the early age of metal use. And he has a coat made of different furs. He had a cap of a bear, a fur. He has a little knife. He had this axe, which was a very interesting finding because he has a copper plate on it. And he has a long bow with arrows and shoes and everything. So he was very well equipped, very well adapted to the environment he lived. And one big question that was striking the people from the beginning, how did the Iceman actually die? In the beginning, as I told you, it was thought that he maybe was wandering around in the mountain, that he was exhausted, that he fell down, he fell asleep, and then he died of cold and hunger and things like this. But this is actually not true. Because in 2001, there was this little thing detected on the radiograph. It's the arrowhead. And this is also funny because you can imagine that the Austrians, they did a lot of investigations from the very beginning. They made X-rays, they made computer tomography, they made a lot of sampling, everything, but they overlooked the arrowhead. And I can tell you that they still today they feel ashamed about this because, and it was also like this that they said, well, maybe you put in the arrowhead later when it came to Bolzano. But this, actually, we teared out the old radiographs. This is a radiograph from 1992, and this already shows the arrowhead. But you also have to say, well, sometimes it can happen because if you're a medical doctor, you're just used to look at the same things. You look at the spine, you look at the joints, but you're not expecting an arrowhead. So we are definitely not blaming our Austrian colleagues, but they're sometimes blaming themselves. So we know 10 years ago, 12 years now, that he had an arrow in his body, but we didn't know really what happened. Does it kill him or just injured him? What happened next? But then in 2007, we performed a new computer tomography, also, again, another medical instrument that evolves. The resolution is much better, and we could better see the arrowhead, and we could also see that when the arrow entered the body, it disrupted a major artery, and there was a massive blood loss. That means he really must have died of this arrowhead within a few minutes. So there was no way to survive this for a longer time. So we could really know from this time on that he was killed by this arrow shot. Additionally, we found, but also in these CT images, that he had a brain injury. You see a kind of brain bleeding, and this showed us that he, well, also had an additional brain injury. That means that he also had this another event that also could have killed him, and it's not clear how it happened. We can just say that it's there. It could have happened that he fell down because he was found on a rock, that he fell on this rock where he was actually found, or maybe the man who killed him with the arrow tried to be sure, took a stone and smashed him against his face. This is the problem we have by studying mummies. We can say how things happened, what caused the death, how fast the death came, but we cannot really reconstruct how it happened. So we can also not say who actually killed him or why he was killed. It's a big issue. There's a lot of theories about it. Some people think there was a kind of war, there was a territorial fight between different groups. But maybe it was just a simple thing about a lady. Who knows? So everything is possible, and this is things we are really this is our limits, let's say. We cannot really reconstruct the whole thing. Also, we can really reconstruct very well how it must have happened. And this was another thing, another evidence we found during our, let's say, crime scene investigation. We found that he had additional wounds on his body, not just only the arrow wound. Here's the thing where the arrow entered the body. Then he had some other hematomas here on the back, and he had a cut wound on his right hand. And this was interesting to see. So what happened? What was going on there? So we investigated this cut wound on the hand. We made histology. We took a little tissue sample, like you do in modern-day pathology in the forensics, and we saw on the one hand here the bleeding. This is a clear evidence for bleeding. And if you did another staining, maybe you can see this greenish blue staining. This shows you that this injury happened already some days ago. So this injury is not directly related with his death, because it must have happened 2 or 3 days before, but there could be a relation. But we also, again, still don't know what happened there. Was there maybe a little fight? Then he escaped, and maybe later he was killed. This could be a possible scenario. So that's why I said there are a lot of open questions, especially how these injuries are related, why he was killed, what were the circumstances of his death, and there are another open questions we are working on, or we worked in the last years, also concerning his his diseases, and I would like to show you now some of these results we have gained in the last years. One thing is the mentioned blood. So we did not really expect to find blood in the Iceman, because we thought about 5,300 years there could be no more blood. Blood, it's a biological thing, degrades rapidly, so why should it be preserved in the Iceman? And there was already some attempts to detect blood in the early years by the Austrians. They opened also some arteries, but everything was empty. So it was thought there is no more blood. But then when we made the histological investigation, we saw that these little roundish objects that reminded us to look like red blood cells, but you never know, it can be also some pollen or plant residues, other microorganisms. So we could not just detect it from this point of view. So that's why we introduced a new technology. They also just came up in the last years. It's coming from let's say, from the nanotechnology. We have here atomic force microscope that is now widely used for specially investigated surface material in a very high resolution. And we also use Raman spectroscopy that can give you really the ultimate proof that you're dealing with red blood cells. This is the working principle of the atomic force microscope. It works with a small cantilever. There's a little tip mounted, and the deflection of this cantilever is measured by a laser beam. It's a quite simple technology, but it works. It's a very precise technology. It works and really down to a nanometer scale. So we're not going so much deep like the Higgs boson, but at least we're going down to the nanometer scale. So, and then we took some of our samples we had already from histology, from the Iceman, and we studied it with the atomic force microscope, and this is some of the results. The first thing we saw is the collagen. Collagen is the main protein in the body that keeps the skin elastic, for example. That is important for the inner organs. So the body is full of collagen, and the collagen 1, the most abundant collagen, has this typical form with this little structure here. And this really looked like, if you see this from the Iceman, it looks like a modern-day collagen fiber from a modern-day patient. It was very surprising to see this very well-preserved material. And when we had a closer look at the little roundish object I shown you before, we really realized it really looks like a perfect red blood cell. You see this typical donut shape, the size fit perfectly so, and we had then also more red blood cells. This is a sample from the arrow wound. We here saw several blood cells stick together, and also again in the atomic force microscope we really then this typical structure, and again together with the Raman spectroscopy, we got the typical pattern to show that there are really hemoglobin inside. So it's not just a cast or maybe something such a structure remained. There's really red blood still present there, and it was a big surprise to us that we have this literally found in the Iceman. It's 5,300-year-old blood, and this is really amazing. It's at least the oldest known human blood. There are some discussion about blood findings going back to the dinosaurs, but this is not that proved in the same way that we could do this. And now we currently work on this, as you said before, try to determine many things, learn from this about his immune system, for example. We were able to detect the blood group that was later confirmed with DNA, this blood group O, and think so on. And I think there's still a lot of information inside this blood that we try to extract. So, just a few words also to other results we had. We had found the Iceman stomach completely filled. This is something also interesting. This was also found just 2 years ago, or 3 years now. That was also always a bit overlooked, that the stomach of the Iceman is still present. It's still filled with material. We have also the liver here. We have also gallbladder stones found in the Iceman. So he also suffered from this. And this is also very interesting information that the stomach was completely filled. That means shortly before he was killed by the arrow, he must have had a big meal, because the stomach is emptied very fast within half an hour. And what does it mean for the interpretation of his death? So he climbed up the mountains. It's a very demanding thing. For sure, then you feel the need to eat something, and he had quite a big meal. But this, on the other hand, means he felt quite safe. So he was not in a rush. So it's not very probable that he was really fleeing from somebody. It was more likely he felt safe. But somebody must have followed him or waited for him and then shot him in the back. So this is just what I already said to sum up, that we now already can reconstruct very well the crime scene, what happened, we can reconstruct how it happened, but we have no idea why it happened, who it happened. It's also interesting to understand that the arrow, when he was shot, the shaft was pulled out of his back, most probably by the one who shot the arrow, to maybe, yes, make nobody understand who shot the arrow, but in the end we don't know exactly, and we have also not found any evidence for any other people there. So we are now currently, this is a current project, and I have to go back tomorrow to Munich because we have in Bolzano another meeting on this. We have found the stomach. We are now analyzing the content. What we have seen immediately, there's a very high fat content. You see this agglomeration of fat, of lipids. So now we want to understand what this is. And we are doing, the first thing was to do some histological, some microscopic work. We found a lot of plant evidence, the wheat grain. We found some muscle fibers. And we could already identify on genetic testing that this comes from ibex. So his last meal was mainly composed of ibex and several plant residues. We still don't know what the fat contains. It could be animal fat, but it could be also a vegetable fat, or it could be also maybe a kind of cheese. This is still not known whether they already had cheese or used cheese. And this we would also like to find out in the next time. And finally, I would also mention just what we found out with genetics when I managed to get this further. Yes. So we already, 2-3 years ago now, we made a complete sequencing of his genome. So we detect, we're really able to read all his genetic sequences, and it turned out that the DNA was beautifully reversed. We could almost reconstruct his full genome, about 85% of his genome. And this gave us a lot of information about him, about his origins. We could detect the so-called haplogroup. That is nowadays a very rare group. You can see here the distribution of haplogroups around the world. And it's interesting, we find very close groups in modern-day Sardinia and Corsica. These are small islands close to Italy and France. And obviously, when the modern-day population, they all came from the Near East and entered Europe and distributed all over Europe, they remained more stable in Sardinia and Corsica and were mainly replaced due to a lot of things in Central Europe, and obviously also with the population of the Iceman. And now we currently try to also understand whether they are, let's say, the population the Iceman came from is still present in South Tyrol. We're making a big study also on the modern-day population to see how the population has changed over time. And maybe there are still some relatives living of the Iceman in South Tyrol. This we also try to find out. This is a current reconstruction that is in the Museum of South Tyrol. This is how he could have looked like. But I have to tell you, the so-called facial reconstruction is always a kind of artistic interpretation of the Iceman. So I'm not really so happy with this, because for me it looks too old. A man in the middle of 40s. For sure the life was more demanding then, but they made him really look a little bit like suffering old. And I think this is not really true. What is also interesting, what we could detect by looking at the genes, he had brown eyes, not as thought before blue eyes. He was lactose intolerant. He still not could digest milk, so maybe it's very unlikely that he ate fresh cheese at least. He had a significantly increased risk for cardiovascular disease. And this is very interesting. He had already this genetic predisposition for such kind of diseases that we think that these are all modern-day diseases that just maybe emerged in the last 100, 200 years. But obviously, the genetic modifications were present in this population already more than 5,000 years ago. And we found out that he suffered from borreliosis, Lyme disease, which is transferred by ticks. It's also the oldest evidence for these diseases in the world so far. So this is a little summary of our findings. I would just to point out, we have put on our internet site, you can find it here, where we put high-resolution images of the mummy on the internet for free. So every one of you is invited to study the mummy, have a detailed look of the mummy. We've also put it in some images with UV light, so you can see better the tattoos. And we also have put in some 3D images, so just to have a better impression of the Iceman. So a lot of people to thank, that colleagues of us, there are much more that are involved in our studies, and I would like to thank you all for coming here and for your attention. Thank you very much.
Thank you very much indeed.